Hi guys. We hope all of you are doing good. Our today talk is about fighting Falcon or F-16. So let's get started. Before you go in video, hit that subscribe button for more videos. Friends, story of fighting Falcon starts with John Richard Boyd, who was a United States Air Force fighter pilot and Pentagon consultant during the second half of the 20th century. His theories have been highly influential in military business and litigation strategies and planning. Beside this, Colonel John Boyd was experienced in combats, and his experiences in the Vietnam War revealed the need for air superiority fighters and better air-to-air training for the United States fighter pilots. Further, based on the experiences in the Korean War and as a fighter tactics instructor in the early 1960s, Colonel John Boyd with mathematician Thomas Christie developed the energy maneuverability theory to model a fighter aircraft's performance in combat. Here, we would like to tell you that energy maneuverability theory is a model of aircraft performance, and it is useful in describing an aircraft's performance as the total of kinetic and potential energies or aircraft-specific energy. It relates the thrust, weight, aerodynamic drag, wing area, and other flight characteristics of an aircraft into a quantitative model. This allows combat capabilities of various aircraft or prospective design trade-offs to be predicted and compared. In the late 1960s, Boyd gathered a group of like-minded innovators who became known as the Fighter Mafia, and in 1969, they secured Department of Defense funding for General Dynamics in Northrop to study design concepts based on the theory. As a result, in May 1971, the Air Force Prototype Study Group was established, with Boyd a key member, and 2 of its 6 proposals would be funded, one being the lightweight fighter program. The request for proposals issued on the 6th of January 1972 called for a 20,000-pound class air-to-air fighter with a good turn rate, acceleration, and range, and optimized for combat at speeds of Mach 0.6 to 1.6 and altitudes of 30,000 to 40,000 feet. This was the region where US Air Force studies predicted most future air combat would occur. The anticipated average flyaway cost of a production version was $3 million. This production plan was only notional, as the US Air Force had no firm plans to procure the winner. To reflect this serious intent to procure a new fighter bomber, the LWF program was rolled into a new Air Combat Fighter or ACF competition. This was announced by US Secretary of Defense James R. Schlesinger in April 1974. In this regard, 5 companies responded, and in 1972, the Air Star selected General Dynamics Model 401 and Northrop's P600 for the follow-on prototype development and testing phase. GD and Northrop were awarded contracts worth $37.9 million and $39.8 million to produce the YF-16 and YF-17, respectively, with the first flights of both prototypes planned for early 1974. On the 13th of January 1975, Secretary of the Air Force, John L. McLucas announced the YF-16 as the winner of the ACF competition. The chief reasons given by the Secretary to select YF-16 were the YF-16's lower operating costs, greater range, and maneuver performance that was significantly better than that of the F-17, especially at supersonic speeds. Another advantage of the YF-16, unlike the YF-17, was its use of the Pratt & Whitney F-100 turbofan engine, the same power plant used by the F-15. Such congruence would lower the cost of engines for both programs. And finally, the United States Air Force inducted YF-16 as F-16 Fighting Falcon on the 17th of August 1978. Since then, F-16 is in service, and it is primarily operated by USA, Israel, Pakistan, Egypt, and Turkey. The F-16 is a single-engine, highly maneuverable, supersonic, multi-role tactical fighter aircraft. It is much smaller and lighter than its predecessors, but uses advanced aerodynamics and avionics, including the first use of a relaxed static stability flight control system, to achieve enhanced maneuver performance. Highly agile, the F-16 was the first fighter aircraft purpose-built to pull 9G maneuvers, and can reach a maximum speed of over Mach 2. Innovations include a frameless bubble canopy for better visibility, a side-mounted control stick, and a reclined seat to reduce G-force effects on the pilot. It is armed with an internal M61 Falcon cannon in the left wing root and has multiple locations for mounting various missiles, bombs, and pods. It has a thrust-to-weight ratio greater than 1, providing power to climb and vertical acceleration. The F-16 was designed to be relatively inexpensive to build and simpler to maintain than earlier generation fighters. The airframe is built with about 80% aviation-grade aluminum alloys, 8% steel, 3% composites, and 1.5% titanium. The leading edge flaps, stabilators, and ventral fins make use of bonded aluminum honeycomb structures and graphite epoxy lamination coatings. Beside these, an upgraded engine, capability for most modern weapons, conformal over-wing fuel tanks and an infrared search and track system, and targeting pod capability, improved data links, precision GPS navigation, and an automatic ground collision avoidance system were also incorporated among other improvements. There are some structural upgrades, meaning the upgraded type could stay in service until 2060 or so.